when we are doing this learning is, don't afraid to ask question, and don't feel like, okay, I will be asking such a silly question, or I should be not asking these questions, what other will think, right? Because we all are here for learning. There are questions which I may not able to answer. I will try my best to go back and try to find the answer, and then come up with the answer. If I know something, I will try to answer as much possible. So let make it more interactive, because we all are here to learn. Okay. So I was telling earlier, like how analytics has been evolved. So earlier, when we used to be an analytics, when we used to think of an analytics, right? We used to have analytics primarily more around the BI or business intelligence. I will be using a lot of acronyms, and if you don't able to understand any of those, like ask me. So earlier the ask was, hey, I have this database, right? And in a database, we have a mm, sorry, this is, let me clear. So we have this database, and we have this BI tool. It can be any BI tool. It can be your,
I'm sorry to interrupt you, Navneet. Are you drawing something that we should be able to see on the whiteboard?
I'm not sharing my screen. I think, yes, I should be sharing my screen. And thank you very much for reminding me.
Thank you. Yep.
Okay. Uh, so this is what we had, this database. Okay. So I'm talking earlier, like how analytics has evolved, right? So we have this database, or we have this files, like a lot of files, and all those things is being kind of accessed using the BI. It can be any CSV file, it can be an Excel file. Here we have a databases like, Oracle, MySQL, MS SQL, etc., etc., right? So all kind of a databases. And then we used to have a BI. So in a BI, what we used to do is, we used to have, or when I say the databases, you can think of, or the data warehouse as well. You can include like any data warehouse. Okay. So we used to do an historical analysis. Hey, give me like how my team has performed, how the sales has been done year over year, or month over month, right? This kind of a reporting. We used to build like pie chart. We used to have a tabular report, etc. But primarily, the whole idea is more on the historical and the batch. So this is the two things which you looking to remember when we how then evolve, right? These are the two common concepts, and we are repeating this again and again. Okay. So the BI was, or business intelligence was dependent on, like, okay, we used to bring the data in, and we used to have a lot of data, and now we used to build some kind of visualization, and we wanted to have some reporting is being done on top of it. uh, we are still doing this one here, but the problem with this, historical reporting, or BI reporting, is, first of all, it's like, it's a batch. So you are not you have to have data being brought in, processed, and then you able to use for your reporting. Okay. So if I have to do some near real time or real time reporting, that was not being supported by using this approach, as it was dependent on the historical data, right? So you will be not able to generate the real time or near real time insight. And this was is like other thing which you will be hearing. Hey, my organization wanted to go, data driven. My organization was looking to build data as a service. My organization wanted to do a data democratizations. All the terms are same. And what does it mean is this reporting, I have a dependencies. In main, I have a BI developer who's used to build, dashboards for me. And that dashboard is being consumed by the rest of the company. Okay. So when I do that, let's say there's a change in a requirement. Uh, he built some kind of a dashboards. Then there's a new dashboards or new requirement which come in. Then this will be a flow cycle. Hey, he used to give this to the BI developer, and then BI developer again, used to build the dashboards, and then rest of the org use it. So this will be introducing lag, right? Because you are not getting your report being done in a timely manner. Let's say I'm an executive. I'm sitting in some kind of a business meeting, and I wanted to have reporting being done in a real time, or I wanted to have my dashboard being built, or I wanted to do slicing and dicing of my data based on the need or what I'm talking to my customer. So this BI reporting, which we used to have, is no longer kind of viable for me to use. So next question you will be asking, hey, does it mean like we don't have a scope in a BI reporting if I'm going into BI reporting? The answer is no. This BI reporting is still being used by many, many, many organizations. However, it's being used only if you have a batch job or batch need. You're not looking to any real-time reporting. You have very specific set of requirement. Hey, I wanted to have this monthly, this very specific set of report being done. And based on the data which is sitting in my data warehouse, my data lake, my uh, m- uh, file system, etc., etc., that I will be doing. So fast forward, now we are having something called real-time reporting or near real-time reporting. And the definition varies. So for someone like, okay, if someone, for instance, if I am if I am doing monitoring my clickstream data, like, okay, or if I'm monitoring my log stream or log data, and I see, hey, I have a customer visiting my website and I want to offer him something, right? How many times it's happened to you? You visiting any website, and all of a sudden you got a pop up, hey, we are having this offer going on, and they are very, very accurate in terms like, okay, if you're visiting this particular page, if you're looking for any shoes or anything, they will be, hey, we are having this offer going on this one. You're able to apply this coupon or etc. So that is more like near real time. The customer is visiting your website, they spend some time, maybe a few seconds, and all of a sudden you will start getting all kind of a pop-up, right? And you are getting out from there, and then all of a sudden when you in all the searches and everywhere, you start seeing that promotion and everything as such. So that is more at near real time. Again, right, if you have any transactions being happening, um, let's say you know uh, you have a credit card and there are some fraudulent activity has happened against your credit card. You will be getting an instant notification, hey, someone has made some transactions against your against your credit card. You may want to call customer care, or maybe banks are very proactive and they are blocking your card by them, right, by themselves itself, and then you will be calling bank, and or they will sending a notification to you. Do you recognize this transaction? So this is we are having near real time or real time analytics, right? So what we had earlier is this is more around the rule base, where you will be having specific set of requirements where you will be building, and this is more around near real time. So when we talk about analytics, this is how it's being evolved, right? Having the batch to a near real time, having earlier we used to bring the data, process it, and everything as such. Now we were bringing the data in a real time. We are processing the data in a real time, and then we are generating the insight. It can be any insight, like whether for fraudulent activity, whether for my e-commerce website, or any XYZ use cases, right? Now we are having one more, which recently in very kind of a hot in market, is now we are moving towards generative AI, right? So that will be learning from the data which you're feeding to them, and then you will be providing analytics. So we are keeping that out of scope for this course, because even I don't know much about how that going to be play out, and how that going to be part of s- uh, part of uh, this analytics ecosystem. So any questions so far? Mm, yes.
Yeah, just listening in. Go ahead. Like no.
Okay, fair enough. So when we talk about analytics in analytics on AWS, right? So primarily we divide those analytics on AWS into actually five pillars. Okay, and one is we are talking about streaming, and this is very important, especially if you're looking to build your career in an analytics world. Other one is big data. The third one is your search. The fourth one is BI, and the fifth one is advanced analytics. So when we talk about streaming, right? Remember, earlier I talked about near real time use cases. How I'm able to do a near real time uh, analysis against my data. So all the services being used to do a near real time analytics, right? That will primarily come under the streaming world. So what AWS offer is something called Amazon Kinesis. Okay, don't worry about this namings for now. I will be, because in over the period of times, right, we will be learning all these services. Just remember like where all this sits in. So this streaming, for if I have to bring in the real-time data, there are service called Amazon Kinesis, which let you bring the data in a real time. So you can have your clickstream data brought in, or you can have your log data brought in. You have your transaction brought in a near real time. Uh, we have something called Amazon Managed Kafka. We call it MSK. Okay. So this is a managed service offered by Amazon to run your Kafka workload. So Kafka is similar to Kinesis, but it's more on open source world, right? Which let you allow you to bring the data in the real time. Other one is your Kafka. You can run your Kafka itself on EC2 or any other machines like on your AWS, but I'm just listing down. There is something called Kinesis Data Analytics. And other is like you have a Kinesis Firehose. So this is the part of the Kinesis family. This Kinesis, Amazon Kinesis Data Analytics, and Amazon Firehose. So which let you data kind of bring in. Other which is being famous in a world is, if I have to go on a Kinesis on a streaming itself, is apart from what all I have listed, is you can have your um, uh, Spark streaming, right? You have your Flink. The KDA is a managed offering of Flink. So as I mentioned earlier, don't, and when I say KDA is a Kinesis Data Analytics, right? So this is the managed offering of a Flink. So these are the services being used when we do an near real time or real time analytics, and that being like, okay, if you're doing in streaming, and why it is important, right? So, and as I mentioned, it's being we have this 4 or 5 think of pillars. Every service itself, you can be really good in Kafka, and you have a number of jobs. You can be really good in Kinesis, you can be in a number of jobs. So you have not to learn all the services which we're going to talk about in this entire session. Hey, I'm very interested in near real time. I'm very interested in the streaming world of the analytics. You can pick any of this service, especially this MSK and Kafka, because it's being open source and being used by many organizations, even outside AWS, right? Sorry, this Kafka, and you can be really good on a Kafka, and you can start applying for jobs there. So I'm wondering if any of you have any experience working of any of the services, or you have tried out the services in past.
No, I don't have.
Okay, perfect. So no problem. So now let's move to the big data space. Okay. So where we say like the big data space is primarily more around processing the big data. So have you guys heard the term big data?
Yes.
Yes. Mhm.
So any of you don't mind coming out of mute and tell me what is big data is?
Data with high volume, high velocity, and high variety.
Okay, okay, that's good to know. Uh, what else?
It's an open source. Mm.
Uh, open source. Okay, what do you mean by open source here?
I mean, the code and everything is available. There is a community which develops and makes improvement to the big data
Okay,
technology.
okay. What else?
It can be structured or unstructured.
Okay, that's good point.
It has a lot of management challenges.
Mm, okay, okay. What else?
And it requires infrastructure, everything end to end, like all the components in the pipeline needs to scale to manage big data.
Okay, okay. So that is more around you're talking about. These are the characteristics of the big data. Okay.
Mhm.
Uh, so, but what the big data is in by definition, right? Okay, it's a three V's: open source, structure, and structure. All those are really nice, but if I have to make you understand, okay, can be a 1 terabyte data can be a big data. If I have to just ask simple, hey, I have this 1 terabyte of data, can I call this as a big data?
Yes.
Why?
Because it depends, right? Like right now we have one, but it can become 1 petabyte at some point, right?
Okay, depends, because it can be a 1 petabyte
At some point.
in future, right? That's what you're asking. Okay. I said like, okay, it's not going to be 1 petabyte. It's always going to be 1 terabyte, regardless. So is going to be big data, or you're going to call it's a big data or not?
Maybe not.
And why not? You just said yes.
And because I thought I was planning for the future.
Okay, so if I'm not planning for a future, then why it's not a 1 terabyte data is a big data?
If 1 terabyte is currently in a manageable schema and it is you have some relationship and it is relational, and we don't need the big data technologies to manage this. We have simple tools and we can manage it well, and then I don't see a reason to call it big data. Then otherwise we'll be just like uh, using unnecessarily a lot of technologies to manage something that is already manageable. That's what I'm thinking when I'm saying it need not be called big data.
Okay, so yes. So again, right, let me give you some context. And if you are in open if you are in a position where if you are in an interview, and if I'm in an interview, I do interviews like, I just have an open-ended question like, hey, do you call what's the big data, and do you call like 1 terabyte of a big data space is a big data, right? Having the understanding what the big data is all about, right? That is where your answers lies. Not all those things which is there in internet, like 3 V's and all 5 V's, unstructured structures. All those are really nice, but that's not the clear understanding of the big data. Depends, as you mentioned earlier, for what I'm talking about a big data space, right? Let's say I have a mobile, and in a mobile, I have this 1 terabyte of data, right? And I have all I have 1 terabyte of data which I'm looking to store, and my mobile is only allow me to store 500 GB of data, right? For me, that's a big data for my mobile.
Mhm.
If I have a laptop where I only have a capacity to store like 1 terabyte of a data, right? That may or may not be a big data for me, because hey, my or maybe in a laptop, I'm able to store 5 terabyte of data or 10 terabyte of data, but it not I'm only have a 1 terabyte of data there. So it may or may not be the big data for me for my laptop. However, when I go to a server where I can store 100 terabyte of data, and when I say, I'm looking to store just 1 terabyte of data, that is not a big data for that particular infrastructure or that particular system, right? So big data primarily mean is you have resources in terms of compute and in terms of storage. When we say compute, you're primarily talking about your CPU and memory. Okay. When we talk about storage, storage is self-explanatory. So if I have, let's say, in my laptop itself, I have I have capacity to store 10 terabyte of data, but I only have 8 GB of RAM. So how my laptop is going to work with 1 terabyte of data with 8 GB RAM, right? It's not going to be performant in a way which I want it to be. When start opening a file, just think of, like, if you have a very big Excel file with I don't know, with like max number of record. When you try to open that simple Excel file, sometime your computer hangs, right? Because it do not have that enough memory to hold the data for you to open it. Then you have to restart your laptop or anything as such. But I say, hey, I'm bringing that Excel file, storing in Amazon S3, and then I'm using an opening there. using some, some other services, which I will be talking later, that can be easily done. So that's not a big data for me, right? So as someone as mentioned earlier, right, it's depend like what kind of a compute I'm using, what kind of storage system I have, and based on that, whether that's a big data or it's not a big data for me. Make sense?
Yes.
Right.
Yeah.
Okay. So all those things where we were earlier, yes. So we were talking around, all the big data services which we have.
So, Navneet, here's my question. So, can we define big data when asked over an interview as it is based on it's a perspective as to well based on the computational space storage uh, capacity of a system?
So I will, if I have to answer in an interview setup, right? I will be doing a follow up. Hey, can you define me big data? Yes, big data are the datas, right? Which can be a structure, and structure that has a it has a characteristic of 5 ways which allow you to volume, velocity, variety, and venacity, and there are one more V, right?
Mhm.
And or 3 V's or 5 ways. So that's if I can go with the definition. If someone just asks me what's the big data is, right? But if someone asks me, hey, can you tell me if 1 terabyte is a big data, right? If someone asking me a follow-up questions,
Uh-huh.
that's where I will be started doing my reasoning. uh, yes, it can be a big data if you're looking to have a system where you do not have enough compute power to manage the data, or you do not have enough storage to manage that 1 terabyte of data. That can be a big data. But if you have a compute and a storage to manage that 1 terabyte of data, that is not a big data. Okay, so again, it's as I mentioned earlier, it's depend like what kind of a compute and storage capacity you have, and that will be defining the big data definition.
Okay, so that's the first we give the definition, then based on the follow-up question we answer.
Exactly. If someone is
So,
asking open-ended questions, right? But if
mhm,
someone just asking, hey, what's the definition of a big data? Then all the things which you have described for a big data, right? Uh,
mhm.
that earlier here, like it follow the characteristic of 3 V's. It can be structure and structure. It has a lot of management challenges. All those things are nice to highlight as a definition of a big data. But that is more on the characteristics of the big data. But if you're looking to understand what the big data is, this is how you should be building your understanding. If I have a system which not allow me to store that amount of data which is being asked, that it means it's a big data. And if it's like, just think of like, hey, I'm running this small shop, right? For me, 1 terabyte data may be big data. But if I'm a Google kind of a world, or if I'm Amazon kind of a company, or if I'm a Facebook kind of a companies, I will be generating the petabyte of data almost like daily. So 1 terabyte is not at all a big data for me. Okay, so again, it's depend like for which system it's being asked.
Okay, thank you.
So here I said, like, for the big data, when we talk about, we use services like AWS Glue, which allow you to perform ETL on your big data. Then we have something called EMR, which is Elastic Map Reduce. If you have heard of Hadoop, then it's a managed offering of Hadoop. Okay. We have something called Athena. We will going to learn everything, all the services in our upcoming sessions, which allow you to perform a SQL query. And now it also offering the Spark as well. And then we have that optionally I'm putting the Redshift as well, because we consider Redshift also as a part of analytics, but again, it's a data warehouse. Okay. Uh, any questions here on a big data before we can move to the search?
Is it recording the screen also?
I'm recording the entire screen, yes. Okay. So search, right?
So,
Have
Navneet, what was that? The after Hadoop, what was the name?
it's Athena.
Okay.
Yeah. Yeah. I'm so sorry for, with my writings here. Um.
No, actually, I'm also doing some notes, so that's why.
Okay.
Okay.
Yeah. And we are recording this session. I make it available for you to, so you can, able to learn what I written, or maybe I can go better on the writing. Okay.
Yeah, yeah.
Next is search, right? So what the search is? You must be wondering, like, what kind of a search analytics you will be doing. Any idea there, or how the search can be part of the analytics? Okay. So just think of, like, hey, when I'm going to Amazon, right? I will be doing a search. Give me shoes, right? That's very generic search. But based on that, it will be listing me all the shoes there, right? And then you're going to have your search relevance there, right? Where what kind of shoes it should be recommending, right? Now, someone has paid like, for promotion, then that will be coming on the top. If someone has not a paid, like, it's not coming on the top. If it's a kind of, top selling product, maybe it's coming on a top. If it's not top selling product, it's not, maybe not coming in a top. If it's a top selling and it's a reasonable price, it will be coming on a search. So we call it search relevance, right? Okay, when you perform any search, how the search relevance is being set, that's how the product is being listed. Or you all working, right? So when you work, right, if you use any your like office laptop, all the things which you do, that is being tracked, right? So that is being like log. Or if you have a machines, right, like, say you have a server being running, all those server log, that is being get tracked and everything as such, right? But if something went wrong, how I'm able to go and look and able to identify the trace, right? So that's where the search comes into picture. So you can have an application, you can have something called observability, which will be technically monitoring your application and see how that is being performing. Maybe there is a throttling happening when you go on the payment, or the payment page, when you, like, moving from one page to another page. It used to take, like, let's say it used to take milliseconds, now it started taking few seconds, or that, like, maybe there's some performance impact happening on your website. You want to track all those things, right? So that's where, like, if you have to go back and do a diagnosis, hey, where the issue is happening, right? That's where, like, you will be building those observability and everything as such. That's where the search comes into picture, right? Log analytics and observabilities and all those use cases. So we have something called a service called open search, or you can call it Amazon open search. And then Amazon, this is Amazon open search. This is managed by the Amazon. And then again, you have an open search itself. This is Apache open search, right? So which is an open source service. You can have an elastic search, which is being managed by a company called Elastic, right? It used to be an open source, not anymore. So, and then you must have heard of Solar, right? That is again, it's an open source. Sorry, Solar. It's an open source search monitoring service. So this is, like, again, as I mentioned earlier, you have not to know all of the service. So if you have just interest on any of the search technology itself, you can learn or pick any of this tool, and you can be an expert and you can start finding the job there. Now we are going to BI. So for the BI within the Amazon, we have something called QuickSight. QuickSight, right? So this is a BI tool being offered by AWS, and this is, I think, it's one of those surveys. If you're new, if you're looking to say, hey, I wanna be, I don't wanna be, going, especially if you're looking to have a career in business analysis or data analysis or anything as such. I think, and you are looking to have a quick start, or you want to go with the easy service to start with, right? I think this is where the quick site will be helpful, and it is very easy to start and very easy to learn, and we will be covering that in our course as well. uh, Apart from the quick site, you can think of any other services being installed on AWS, but AWS offering is the quick site. And now when we go on the advanced analytics, we are talking about AI services, and then we're talking about ML services, and then now we're talking about generative AI services. So this AI, you can think of transcribe, which we have a poly, right? There are many other services being available on the AI space. Uh, on ML, we have something called SageMaker. You must have heard of the name, which led you to build your ML models and test it and deploy it and then inference and everything as such. And now we have a Gen AI, so which is generative AI, all the Chat GPT kind of world, right? So recently we have announced something called Bedrock, as a part of the Gen AI that is still in a beta, right? So these are the services which we have within the analytics space. So now the question is, today's topic was we wanted to start with understanding of data lake, but I thought giving over of 10,000 overview how the analytics or what all analytics things are there. Uh, it will be easy for you to know base of foundations. Now, when we talk about so big data, right, and we have talked around all the challenges which we have within the big data, right? That's where we have a concept of data lake kind of brought in. Hey, I have this much of data sources being generated from different data sources. So even before go there, have you guys have heard of the term data lake?
Yes.
Yeah.
Okay, so any of you don't mind giving me definition of the data lake before I can put my thought here?
It's like a data storage that has a large amount of structured along with like unstructured and just other types of data in it. I think he's frozen.
Hello. Yeah.
You guys able to hear me?
Yeah.
Okay.
Yes. Yeah.
So what's the definition of structured data?
Structured data is just the organized data essentially.
Mm-hmm.
Data that's been like formatted and like pre-processed so you can use SQL to find it. And unstructured data is data that hasn't been cleaned or anything yet.
Okay, and examples?
Like a structured data would be like numbers, I guess, if you had like integers or float numbers. Unstructured data could be things like just files. Maybe you're adding files in your data lake.
Okay, so whether Excel, CSV, what these are the structured data or unstructured data?
Structured.
Okay, why you call it structured?
Because it has a specific pattern it follows.
Rows and columns.
Okay, that's a good definition. So rows and columns. Okay, so yes, so this is a good definition. Someone asks you, hey, what the structured data is, right? So it data which has its definition is being intact in a way like, it will be not frequently changing, it's not nested, etc., etc. That's the structured data, right? You easily able to, the data being stored in more kind of a row and column format. So that's the structured data usually. So if you look at the Excel file, if you look at the CSV file, if you look at the databases, and just again remember the examples, right? Someone has mentioned that integers and numbers and everything as such, that's not a definition of a structured data, right? So structured data is the data which is being stored in a row and columns, and that can be easily readable, etc., right? So you, as a human, you able to go and easily read what the data is all about, right? So that is more on structured side of the data. So Excel, CSV, databases, data warehouse, etc. These are the structured data, which is easily able to read because it follows some kind of a structure. Now, what is and there are one more things comes in between: structured, semi-structured, and unstructured data. So, what do you think of any example of semi-structure?
XML file.
Is is it a JSON as a semi-structure because it's expandable?
Okay,
Log
sounds
files.
log files. Okay, what else? Fair enough. So yes,
Surveys,
all three
which,
all three
sorry.
of them, yeah. Surveys, you can think of it at the end, it's generating some kind of file, right, at the end. So
Yes.
all three are a good examples, right? uh JSON, XML, and a log file. And why we call it semi structured?
Because there is some pattern to it, but it follows a key value kind of a pattern. Not necessarily that all the records are going to have the same number of attributes.
Exactly. So semi structure is just more like, hey, it's somehow you able to go, and when you start looking the data, you're able to make some sense out of it, but you're not able to extract all the attribute around of your data set, right? If I have an XML file, if I'm going and start reading that XML file, I should able to make some sense out of it, right? Hey, this file looks like, this is what the file is. But if I have to make up, analytics around it, it's going to be super, super difficult for me because I don't know what all attributes are there, what's the relation being built, etc., etc. Same goes with all other files as well, right? JSON and a log file, etc. Uh, Now we have this unstructured. Was a couple examples.
Text files, video files, audio files.
Videos, audios, image. Any other examples? Okay, so yes, or any other examples, right? I'm generating some scientific data or any other data, right, which is being, or any medical data which is being stored, right? uh, all those data come as an unstructured data because it's not very easy to kind of go and have a look and make a sense out of it, right? Or it's not very easy to extract the definition of the data. So the advantage of having the data is now organization, oh sorry, advantage of having the data lake is now organizations are becoming data driven, right? Try to collect all kind of a data from all the different data sources, right? So if I say, hey, this is my data lake, I can have any number of data sources. Like let's go with the traditional data sources. We can have a databases. We can have a data warehouse. We can have a file system like CSV, XML, Parquet, ORC, etc., etc. Right? We can have videos. We can have audios. We can have log data. We can have uh, image data. We can have medical file formats which we have all. So the idea is like as a data lake, it allow you to bring all kind of a data and have the data being stored in your data lake, and that's the advantage of having data lake, right? It can be stored structured data, unstructured data, and semi-structured data. Other very important concept of a data lake is decoupling of storage and compute. Okay, anyone can like help me understand what this mean is decoupling of storage and compute? Have you guys heard of this term decoupling of storage and compute?
Yes.
Okay, so what does it mean?
If we take a laptop, for example, right, like
Hmm.
the compute storage, everything is together. And then as we go into bigger and bigger data, like you explained before, then we need to horizontally scale. And
Hmm.
one of the ways we scale is decoupling the storage from compute. So we still have like a network of storage devices separate to the compute. This way we can mix and match and manage it better.
Perfect. Yeah, exactly. So just think of like we used to have, maybe I can get this one. We used to have the database, okay, and database is only capable of storing 1 TB of data, and it has a 16 GB RAM, and it has a maybe 8 core, okay, vCPU. Now business requirement came in, hey, now we're going to have a 2 TB of data, right? And my this server or this database is only capable of storing 1 TB of data. If I have to do that, I have 2 ways of doing it, right? I can have one more system being built which let me store 1 TB of data and with same configuration, or I can expand, or I can add one more terabyte of data here, right? This one. So scaling like horizontally and vertically, which you're looking to do. However, I can go as much as, like, let's say I have built a system where I have 1 TB data, or now I have a 2 TB of data being stored in my system. Now I have just 32 GB RAM, and what was the vCore earlier? 8. So I have this 16 vCore, right? Now I'm storing 2 TB of data here. Let's say I have a requirement of now store 8 TB of data, right? Either I can build 4 2 TB of system that management going to overhead, or I can just have one more big system where I can have the data being stored. But if I keep increasing in a way, I will be increasing this to component as well, right? But in I may or may not have a requirement to access, or to I just want to access 1 TB of data, or I'm just using 1 TB of data for my work. I don't have to Why I have to pay about all these resources when I have to just use 1 TB of data at a single point of time, right? So this is kind of wastage of your resources. That's where the concept of decoupling and storage and compute comes into picture. You can have as much as data being stored. You can have a petabyte of data being stored in your data lake, and then whatever the compute, like let's say I have this petabyte of data being stored, and I only looking to access this 1 terabyte of data from my this entire database. So I can have a compute power just accessing this like this much of data, this one terabyte of data, right? So this is the decoupling of storage and compute. This way allow me to, even out of this 1 petabyte of data, if I go with this previous architecture, I have to have a system which let me hold this 1 petabyte of data. And similarly, I have to increase the compute power in a way so I should able to manage this 1 petabyte of data. But when we do a decoupling of storage and compute, I have not to worry about the compute power. I will be storing as much as the data is needed, and then I will be having as much as storage being required for me to, you know, to read that subset of the data. Is it clear now?
Can you repeat it actually? I
Okay.
missed that part. Okay.
Okay. So you followed this part here?
Yeah, the next part also I followed. The last
Uh,
slide you explained.
so let's say my requirement is keep increasing. Now I have a petabyte of data being stored, right? So what I can able to do in a data lake, I can have the data being stored as a petabyte of data. But if I only have a requirement to access terabyte of data out of petabyte of data, I can have a separate compute which is being built. So remember, we had this compute power to this much of compute power I needed for me to read that petabyte of terabyte of data, right? So I can only go with a compute where I can have a 16 GB RAM and 8 core weak CPU just to read this data. I have not to worry about creating entire system for me to perform this petabyte of data, able to perform the compute on this petabyte of data. Make sense?
Yeah, it makes sense.
Okay, perfect. Other important characteristics. I know we are running out of time. We already 9 minutes past. I hope you guys have like 5 more minutes, and then I will be wrapping up this one. Okay. Other important concept when we talk about mm, data lake is something called schema on read. Any idea what the schema on read is?
Is it a dynamic schema?
No.
Okay.
So just think of like, hey, schema on read is when I have this data being stored in my data lake, all right? And I have to read the data using some SQL, right? So when and only if I'm reading the data, I have to worry about constructing the schema. If tomorrow there's a change in a schema, let's say I brought a new file and that new file has a change in schema. Whenever I'm constructing this SQL again, let's say I have to drop this I have created this table with this previous file schema. Okay. Now if I have to drop this schema here with based on the new file, I should not be dropping my data. So just think of, let me take a step back here. So we had this database. Okay. In a database, how the data is being stored in the form of tables, right? Tables have your row and column. So it has a rigid schema. So if I'm dropping this table, let's say tomorrow there's a change in the schema. If I'm dropping this table or creating the new table, what will happen to this table or what will happen to this database, this data?
Yeah, we lose the data.
We lose the data, right? We lose the data. Okay. However, in a data lake, as it's like it's a schema on read, your data will remain there and you able to read the data, even even there is a change in schema. So with that, I will be giving you an example, or maybe I can just demo you what I'm talking here. Okay. So I'm wondering if you guys has got an opportunity to build your AWS account or create your AWS account. Okay, so here is our S3 bucket. Okay, and I have all kind of a data being stored in my S3. So you can think of this is my data lake, and I will be storing all kind of a data, right? So it's impossible for me to go and look into each and every file system and see what kind of a data is being stored, right? That's where we're going to learn about how you will be building the governance on top of your data lake, so you're able to see, like, okay, able to see. But just for this example, I will be just going into this service called Athena, which let you do a SQL query against your data lake. Okay, don't worry about it. It's just to give you an understanding the concept, and once we start learning about all these services, you will have a better understanding. So let's say I have this data set here, right? I will be running this query, and I will be getting this output here, right? So if I go and show you definition here, so if I just generate DDL, it will be telling you, like, okay, I have data being stored in this S3 bucket. You guys able to see my screen here, right? Uh, let me zoom in.
Yeah, we can able to.
Okay, so if you see here, this is where the data is being stored. Okay, so in a database world, if I just simply go and let me copy paste this here somewhere in notes. If I if I in a database world, if I will be dropping this database, this table here, right? What will happen is I will be losing my data. Okay. Schema on read is whenever I'm just reading the scheme, whenever I'm just reading this, because I do not have a permission to delete this one. Let me find some other table. Okay, I have to go and update the permission. So again, right, once we start talking about security and everything as such, we will be going to learn about um, this concept as well, like, okay, how you able to secure your data lake, etc., etc., right? So we had this Amazon review, view tables, and I had this Parquet file, right? That was the file. Yeah, this is the file. Let me grant an access. I will be going with admin. Just think of, I have applied the permission where I'm not letting my user to delete the database, right? So that's a permission. However, I will be changing this, and I will be giving the super here, right? So I will be able to perform any operations against my data here. So I have just granted access, and I will go back in Athena and try to drop the data there. So if I just run this drop table now, hopefully it should let me run this statement. Okay, so if you see here, I just drop the data. So if in a database, if I'm dropping this table, I will be losing the data. Whereas in a data lake world, as my data, as my segregation of compute and the storage is there. Remember, we talked around the concept of having the decoupling of storage and compute. I can have a, any number of data being stored here on this one, and I can use as much as compute being required for me to process this data. So if I go back and recreate this table, I should able to read the data again. Okay, okay, I should able to. I have to grant access to this bucket as well. Okay, but the idea is like you as a user able to go and let me go back then to some different account. This account has a permission and everything being set up. I was building this account for us to showcase how the permissions and everything work. But let me go back on this different one. But the idea is like it allow you to allow once you have data stored in your data lake, you can use as much as power or as compute like this Athena. It allow you to have a compute, like let's say this is my 30 terabyte of a data, right? I am having this 30 terabyte of data being stored. I can delete and recreate this entire data set it all together. So this is the TSB, generate table DDL. I will be reading this here. Hope I don't have any permission issues with this one. So let me go and drop. So now if I go back and recreate this table, right? So just think of like, okay, this is where my data is being stored even before going and recreating it. So this is where my data is being stored. This is the location, right? This is the my S3 bucket where I have this data. And if I can go back and look into in S3, I should able to see my data. So let's go and let's go and view our data first. Let me little zoom in. So this is my data. So see here, this is how the data is being stored here, right? It's as a file. So it's not very easy for me to go and read the file because it's a big files and right, it's very, very difficult for me to read the file. But if you can think of like, it has almost like 32 GB of data. So now if I go back and create, so you got the concept of decoupling of storage and compute here. So if I go back and delete this data here. So this is very important concept. Like especially if you're going for an interview, having a clear understanding characteristics of a data lake, like decoupling of storage and compute and schema and read, all those nice things. So if I go back and rerun this one, I will have my table back. And what I'm doing is whenever I'm reading the data, I will be creating or defining this schema, right? And if you see here, when I'm running, it will be only scanning this much of data and it will be only running this much of time. And then I will be getting paid, means I will be paying AWS to just run this data for here. However, when I do a count star on this one, like it will be going and scanning that entire data set, where it will be kind of I will be paying. So just think of like if I have a terabyte of data and if I only doing only reading 1 GB of data, I have not to worry about paying for the entire terabyte of my data. So that's a decoupling of storage and compute. However, when if there is a change in the schema, let's say what I will did, what I will do here is I have this this entire data set here, and I said uh, let me remove this columns here. I don't need this column. I will be only looking to read few columns, right? Okay, I have to give a bit different name. We already have this table. See, I have removed those columns. Still, I'm able to view the data. So this is like when I'm reading the schema, I'm just defining the schema while reading, or by making by read against my data lake. Are we clear on this two concept? Because this is very, very important when you, especially if you're going on any kind of interview. Schema on read and decoupling of storage and compute.
Yes.
Okay, perfect. So with that, we are I will be in the next in our next session. I will be kind of continuing on this one, and then I will be helping you to understand how that what will, like, how you building your big data or data lake architecture in a way, or building your ETL pipeline in a way to hydrate your big data or to ingest the data into your big data, and then again, right, how we are looking to consume the data. That's where I will be kind of making you understand that pipeline. And once we have understanding of a pipeline, then we start going on the individual services. Okay, so before we can dispose this session, any questions?
Thank you for taking your time and effort to explain all this to us. It was really good. Thank you.
Not a problem. Yeah, so fair enough. I will be sharing this video in a group, so you guys can review it and learn about all the concept which we taught through. If you have any questions, feel free to put on ask in a chat itself, so other can also learn based on your questions, and then we can meet next week at the same time. Okay. So thank you very much for the joining. And the last time, I know I'm kind of broken record here. So I'm doing this one to help to ensure we have this this mandir kind of being built. So if possible, please please contribute whatever you can do that. So thank you very much, and those who have contributed, thank you very much from my bottom of heart. So okay, we'll see you guys next week. Take care.
Thank you so much.
Thank you.
Thank you.
Thank you,
Thank
Noam.
you. Thank you.